let's go over one last theorem of this section. This allows us to determine all the possible roots for any polynomial function that we have in front of us, as long as it's in a sum or difference of terms. So starting off, the theorem tells us that the possible rational roots can be set up so that you are taking factors of the constant term over factors of the leading coefficient. So if I want to label this, for example, 15, I kind of note to myself that the leading term is x to the fourth, and the constant term is 10. So when I want to talk about the possible rational roots, remember, keyword is possible, so make sure you pay attention to that in the directions. We'll always start off with the plus or minus, so we don't have to deal with all the combinations of the signs, because eventually they're either going to be positive or negative. We will always take factors of the constant. So in our case, I'm looking at factors of the constant term, that's 10, over factors of the leading coefficient. So in our case, the leading coefficient is 1. So when you are trying to find all factors of the number, sometimes if the numbers are small enough, we can definitely find them without having to make a t-chart. But I'll remind you one more time. If you were trying to find factors of 10, an organized way to do this is always start off with 1 and the number itself, so 1 times 10. Then just count 2. Does 2 work? 2 times 5 would work. Then notice that 3 would not go into 10 evenly. Neither would 4. 5 does, 5 times 2. But the minute you see repeats in this type of problem, if you take the factors in order, kind of make a little U shape, you would end up seeing 1, 2, 5, and 10 as factors of 10. Now factors of 1, the only possibility would be a 1. So don't have to worry about that one as much. And then what you do is you take all the possible combinations. So the denominator is 1 for all of these, but I'll show you just in case. We'll have a chance in a minute with the next example. But we should be dealing with always plus or minus. What I'd be doing is I just take all of the possibilities. So you would see me write 1 over 1. And I'll use braces to indicate that I have separate factors now. 2 over 1, 5 over 1, and 10 over 1. So now we just take care to reduce, write it in a prettier form. So I'll go sideways just a little bit, or I'll go down. Don't forget the plus or minus and braces. 1 over 1 is 1, 2 over 1 is 2, 5 over 1 is 5, and 10 over 1 is 10. So this theorem is so powerful. What you've just done is you've taken an infinite amount of possibilities and you've narrowed it down to 1, 2, 3, 4. And if we make the plus or minus 5, 6, 7, 8, there's 8 possible factors now. I should say roots instead. So that's really, really nice to go from a random picking of infinite numbers to just 8. Definitely testable if we can do this. So let's try one more together, something that might be a little more complicated. Sometimes the ratios of the two factors, constant and leading coefficient, could cause a little more confusion. So I'd like to go over that one more time. So this last one, you can try the next example on your own if you need to. So we've got, if we're trying to find all the possible roots, always going to start off with the plus or minus to remind myself. And I'd be looking at factors of the constant. So in this case, the constant is 10. And you can say negative if you'd like to, but because we have the plus or minus, we're good to go on that. All over factors of 6. And for the same reasoning, because we could put -6, but because we already have the plus or minus, we've taken care of that. So we just kind of simplified finding factors. So just writing these out for ourselves, we still have plus or minus going on. We just found the factors of 10 earlier. That's 1, 2, 5, and 10. Now the factors of 6. I want to take a mini T-chart off to the side, if you'd like. I'll do that for you. 6 is kind of small enough, but just in case. So we have 1 times 6, 2 times 3, and then we notice we go 3 times 2, we have our repeat. So now we've got our factors 1, 2, 3, and 6. So now we have everything set up. But notice we now have more than one factor in the denominator. So the ratios of all of these combinations will take us a little time. So I'll write them out just to be sure. What I'm dealing with still have plus or minus, and since I'm now separating these into all these different factors, I'll use braces. The first thing I will try to work with myself is I'm going to look at 1, and I'm going to put it all over each of the different denominators. So I have 1 over 1, 1 over 2, 1 over 3, and 1 over 6. And you could do this in any order that you'd like. But I kind of try to be organized myself. The next thing I'll look at is the next factor in the numerator. So that's 2. So I'll take 2 over 1, 2 over 2, 2 over 3, and 2 over 6. And you kind of see me color coding, mainly because when my eyes skip, I end up missing a factor. So feel free, take my technique. Let's work with 5 next. We'll see that we have 5 over 1, 5 over 2, 5 over 3, and 5 over 6. And let's take a look at 10. So 10 over 1, I know it's getting a little messy. 10 over 2, 10 over 3, and 10 over 6. And that is the end of the possibilities. Now, I know it looks a little intimidating. There's a lot of factors going on, but when you start reducing these, you'll notice that you see some repeats. So when you write your final answer, you're going to want to make sure you don't have to rewrite the repeats over. So let's go through this. Let's simplify everything out. I'll start off with 1 over 1, which is just a 1. So we're good to go there. 1 over 2, we're still good. 1 over 3, 1 over 6. That hasn't really changed. Now we say 2 over 1. That's a 2. We haven't written that already. However, 2 over 2 is already equal to 1. So we're good there. Don't have to write that over again. 2 over 3, we have not written. 2 over 6, if you want to reduce it out, that's equal to 1/3. We've already written it. Don't have to write it over again. 5 over 1 is 5. We have not written that down. We're still good to go. No, Leica, we need a little more time here. We have a few more factors to go. I know. Okay, so 5 over 1 is 5. Patience, please. I know we're just as excited. We're almost there. Okay, so 5 over 2. We haven't written that down yet, so we're good to go. 5 over 3, 5 over 6. I know it's exciting. So we are almost there. I'm going to look at 10 over 1. We haven't written that down. Now 10 over 2, that is a 5. We've already written that. 10 over 3, have not written that down. And double checking 10 over 6, if I'm not mistaken, that becomes 5 over 3. We've already written that down. So finally, we have the list of factors. And I know that looks like a lot. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors, but multiply that by 2. These 24 different, when I say factors, I keep meaning roots, 24 possible roots. I'm still stuck on factors, I suppose. And I know that seems like a lot to test, but 24 is a whole lot less than infinity. So kind of keep it in that. Look on the bright side. At least you don't have to test every number out in the world. Now, in a future math class, you may see the importance of understanding why we want to know how many possible roots and what they are. But right now, let's just work on finding the possibilities. And you are good to go. I'll see you next section.